Okay guys, today we are doing flipping out with probability. You are going to need your purplish notes. These don't look very purple now, but your purplish notes and something to write with, a pen or a pencil. Go ahead, put your name at the top if you haven't done so. So probability is the chance of something happening. So it's the chance of rolling a 2 on the dice or a chance of pulling a pink pair of socks out of your drawer. In order to find probability, we're going to set up a fraction. And your fraction is going to have on the denominator, the bottom, your total number of chances, so total chances. And on top, you're going to put chances of wanted. So what are the chances of rolling a 2 or a 4? What are the chances of getting a pair of pink socks? And you're going to use this for every probability problem that we're going to work on. You're going to need to simplify your fraction. And sometimes you're going to turn your fraction into a percent. Sometimes they're going to ask for a percent, like the chance that it's going to rain, it's maybe a 20%. They don't tell you a fraction, they tell you a percent. So we're going to work a few examples together. Number 1, it says, what is the probability of rolling a 4 or a 5 on a fair number cube? And it says fair number cube here. That's usually what they use on testing, but that means a dice, just a regular old dice. So right here, this is called like shorthand. This is the shorthand of probability. It says the probability of, and you're going to put 4 or 5. This means what is the probability of rolling a 4 or 5 on a dice? So in order to set up our fraction is the chances of a 4 or 5 over the total. So the total is usually the easiest place to start. On a dice, it's a cube, and a cube has 6 sides, so the denominator is 6. And a 4 or 5 would give me 1 chance for a 4 and 1 chance for a 5 for a total of 2. Now we set up here, we have to simplify the fractions. So 2 6 can be simplified by 2 on the top and the bottom to become a 1/3. So that's my fraction, but let's go ahead and turn it into a percent. If you don't remember, you need to divide top in, bottom out. And what happens is you end up with a repeating decimal. And so that's 0.33 on and on and on. So it's really 33.3 repeating percent. Now a lot of times you're going to see that written as 33 and 1/3%. They mean the same thing. Okay, let's go to question 2. Given cards that spell genius, what is the probability of drawing a vowel? So what's going to happen is in this problem, maybe you've got the cards in a bag and you want to pull out a vowel. So the probability, remember shorthand, so that means probability of a vowel. Let's figure out the total. So there's 1, 2, 3, 4, 5, 6 cards total. But now I want the chances of getting a vowel. So there's 1, 2, 3 vowels. So I have 3 over 6, which we know we need to simplify. 3/6 divided by 3 on top and bottom becomes 1/2. And then you should know that as a percent is 50%. So you have a 50% chance of pulling a vowel out of that bag of cards. All right, number 3 is for you to do on your own. So pause the video and finish that one and then replay. Okay, now we're going on to part B. Part B is going to talk about a couple different kinds of probability. So we have independent probability. And then down here we have dependent probability. Independent and dependent probability. So independent probability is when one event does not affect the outcome of another event. One event does not affect the outcome of another event. So here's an example. Juan chooses a marble from a jar. He puts it back in the jar, and then Zoe draws another marble. So this is independent of probability because he puts the marble back. So because he puts the marble back, he puts it back in the jar, and in parentheses write replace. He replaces the marble. That's independent. What Juan does after he puts it back does not affect what Zoe can draw out of the marble jar. So it's independent probability. So the second one, dependent probability, is when one event does affect the outcome of another. So the example here says Juan chooses a marble from the jar. He puts it in his pocket, and then Zoe chooses a marble. So because he puts in his pocket, he is not replacing. So that's without replacement, or replacing. So when Juan takes a marble out of the jar, because he's taken one out, Zoe doesn't have the same chance as Juan did as pulling one of those marbles. So that's dependent probability. Okay, so let's go to the back. It says classify each situation as independent or dependent probability. Write the key word or words that help you decide. Number 1, Kobe draws one card from the deck, looks at it, and puts it back in the deck. He then draws a second card from the deck. Well, this is going to be independent probability, and you can abbreviate, because, and it says right here, he puts the card back. Puts it back. So when he goes to draw that second card, his chances are exactly the same as they were when he drew the first one. Number 2, Connell rolls a fair number cube, which we know is a dice, and flips a coin. So it wants to know, is this independent or dependent? Well, this is going to be independent. And it's because it's a cube and a dice. And in parentheses write 2 separate events. A cube and a dice have nothing to do with each other. When you roll this should be a cube and a coin, sorry. When you roll a cube or a dice and you flip a coin, one's not going to affect the other. So that one is independent as well. Number 3, AJ gets one piece of candy from a jar, eats it, and then gets to choose one more. So here's the candy jar. He takes one piece of candy out, he eats it, and then he goes back and he takes another one. This is dependent probability because he's eating the candy. Eats the candy, which means he does not replace the candy. When you eat the candy, you're not going to stick it back in the jar. Okay, one more. Chase spins a spinner 3 times. Well, this is independent, and this is very similar to number 2 up here. Spinning the spinner 3 times does not change it. So 3 times does not change the outcome. Okay, so we've got 2 questions left, number 5 and 6. You are going to do these 2 on your own. Look for the keywords and then decide if it's independent or dependent probability. And we will go over this in class tomorrow.